Okay, hi guys. So from this lecture, we'll be starting off with coupling reaction. So let me put down the heading first. So we have a coupling reaction. Okay. So we have first a CN coupling and second NN coupling. Okay. So let's say we have a reaction like this. We have aniline and we are reacting it with diazonium salt. We will get something like, let's suppose, at a pH of 5 to 7. So what would we be getting? We'll get something like this as our product. Okay, so in this case an uncoupling took place. Okay, let's take another example. Here we have this compound and we are reacting it with again diazonium salt. We'll get something like, again we will actually look into the mechanism of this reaction in a short while, but for now I am just drawing the products. Okay, another example, we have CS3 here and CS3 here, and we have again pH. This lone pair of this nitrogen atom will attack on this nitrogen atom to form something like so. One point to note here is, due to steric hindrance, obviously it won't be feasible for this nitrogen atom with these two bulky CSA groups to directly attack on this nitrogen atom. So what turnaround it would do is it will have a resonating structure wherein negative charge density will come on this carbon atom, and this carbon atom, or ortho and para positions. For these two ortho positions, again we have the steric hindrance. So what will happen is, this carbon atom at the para position, which is having a partial negative charge, will actually go and attack on this nitrogen atom. As a result, we will get something like this product. Okay, so this is an example of CN coupling. Okay, so let us discuss another example where we have something like a phenol and then we are reacting it with this compound. Okay, at a pH of 10 to 11, and we would get something like, again at this pH, O will lose its H plus and have a negative charge on itself, and will create a negative charge density on ortho and para positions. What will then be happening is, the para position would actually attack on the nitrogen atom because obviously of steric hindrance reasons. Okay, so the major product form would be something like this. So let me okay, one reason is obviously steric hindrance, but that is not that much of a concern here, because we don't have a CS3 groups or bulky groups attached to O atoms. The second major point which contributes majorly that why O and N coupling doesn't happen is, if this O will try to attack on this nitrogen atom, what will actually happen is O and N coupling would be there, and as a result lone pair repulsions would be there. Hence O minus will not directly attack on N. Indirectly, the para position, the carbon atom at the para position of phenol will actually go and attack on this nitrogen atom. Okay, and we will get something like this, OH. Okay, so obviously if you draw the intermediary states, you will understand that you will get something like this, and we will get something like double bond here, negative charge here, and this will actually attack on, let me redraw it will attack on this nitrogen atom. Okay, then we'll be getting something like this product, double bond, and oxygen is there. Again tautomerism will happen, this alpha hydrogen would be removed, so tautomerism will happen, and we'll get something like this compound. Okay, so let us discuss the mechanism as to how it happens. So the mechanism is pretty simple. For example, we took an example wherein we reacted in the previous I will just show you there only. We took this example wherein we reacted this compound with diazonium chloride, okay, or so diazonium salt. So the lone pair here will actually go and attack on this nitrogen atom. As a result, this would get bonded with this nitrogen atom over here. This nitrogen atom, I showed it with the underline, got bonded with the boxed nitrogen atom. Okay, the cloudy nitrogen atom gets back its electrons, so it will not have a plus charge anymore, hence the compound is formed. So this is the mechanism. Okay, nothing great, so I'm avoiding writing it again here. Okay, so let me discuss some of the characteristics of this reaction. Okay, so first characteristic is it is electrophilic substitution reaction. Okay, in which negatively charged carbon atom or nitrogen atom with lone pair actually attacks on the electrophile, and the electrophile is, in this case, is diazonium salt. Okay, so second point is carbanion is formed. Okay, as an intermediate. Okay, and otherwise in sulfonation nitration carbocation was formed. Okay, otherwise in sulfonation and nitration okay. Third point is azo linkage in between two carbon ring is a colored compound. So we got the linkage as N double bond and, so N double bond and actually gives the color to the aromatic compound hence formed. Hence we'll just write this as azo linkage in between the aromatic rings gives a or is a colored compound simply. So in the next lecture we will be discussing some more um, on reaction of diazonium chloride as a N uncoupling and C uncoupling. So till then, good luck and goodbye.